morning, sir. My name is Sahil Javed Mulani. Today I am going to present my presentation related to tuned mass damper. It is a damper is device used to reduce the effects of vibration in structures. First is what is meant by tuned mass dampers. First is a tuned mass damper is an engineering solution designed to reduce the structural vibration caused by wind, earthquakes, or other external services or the forces. It consists of mass spring system that precisely adjusted to the vibration of the structures. The mass of the tuned mass damper is carefully calculated and positioned to harmonically counteract the oscillation, effectively minimizing the amplitude of the vibration. Basically, a tuned mass damper is used for high-rise building to sustain the earthquake, the wind pressure, or the external forces. And the next is how does the tuned mass damper work? The oscillation detection. In this, the tuned mass damper system has sensors that detect the structure's vibrations. Then the signal processing. The detected oscillation signals is processed to determine the frequency and the amplitude of the vibrations. The third is counteracting the vibrations. In this, the mass spring system of the tuned mass damper generate the forces that counteract the oscillation, reducing the vibration in the structures. Application of tuned mass dampers. The skyscrapers, the bridges, the cranes. Tuned mass damper is commonly used in tall buildings to mitigate the effects of the wind-induced vibrations and maintain the structural stability. The bridges. The tuned mass dampers can be integrated into bridge structures to minimize the excessive vibrations caused by traffic loads or the dynamic forces. The cranes. The crane's tuned mass dampers helps to reduce the sway and minimize the structural fatigue, allowing for safer and more efficient lifting operations. Next is the advantages of using the tuned mass dampers. First is vibration reduction, cost effective solution, adaptability. In vibrations reduction, the tuned mass dampers significantly reduce the vibration, enhancing the occupant comfort and preserving the structural integrity. In the second stage, the cost effective solutions. Implementing the tuned mass dampers is often more cost effective compared to alternative solutions for vibration controls. In the adaptability, the tuned mass dampers can be customized and easily retrofitted into existing structures to address the vibration issues. The limitation and the challenges of the tuned mass dampers. The tuning complexity, the pace constraints, the maintenance requirement. The tuning complexity contains the calibrating the tuned mass damper to match the specific vibration characteristics of a structure can be challenging. The pace constraints, depending on the structural design, finding the suitability pads to install the tuned mass dampers can be constraints due to large amount of space is required to install that kind of the dampers. The maintenance requirement. The tuned mass dampers need the periodic inspection and the maintenance to ensure the optical operation over the time. The case studies of the successful implementation. First is a Type I 101. The Type I 101 skyscraper in Taiwan implemented tuned mass dampers, noticeably reducing the swaying caused by strong winds. Millennium Bridge. The Millennium Bridge in London has successfully retrofitted with the tuned mass dampers after the excessive vibration were discovered shortly after its opening. The cranes in construction. Various construction objects have utilized the tuned mass dampers in cranes to enhance the stability and reduce the sway during the lifting operation. The final key words or the conclusion. The tuned mass dampers offer an effective solution for reducing the vibration in structures. Their applications span for the tall buildings to bridges and the cranes, providing increased stability and comfort. Understanding the advantages, the limitation, and the successful case studies can inform the future projects and promote the implementation of this remarkable technology. Thank you.